This video will talk about the moons of Mars, Saturn, Uranus, and Neptune. Another video discusses the moons of Jupiter, and another video will discuss the rings of the Jovian planets. We'll start with Mars here, and Mars is interesting because it has some moons that are small, but you might think they would be irregular satellites, but they're small regular satellites in that they orbit in the equatorial plane of Mars. And again, unusual that if they are captured asteroids, that they don't orbit at sort of random angles. But there are two moons, Phobos and Deimos, and let's move on to their photographs of spacecraft flying by Mars, orbiting Mars, have studied these moons, and you can see impact craters on them. Notice they're very small. The scale here is 2 kilometers. That's about 1.2 miles, and so not large at all. And Phobos is interesting, has some streaks that run back, perhaps crater chains from impacts, and you can see a fairly large impact crater on this left end of Phobos. Just to compare to an asteroid, so we have Phobos and Deimos, and then the asteroid Gaspara, and you can see some similarities in the not quite spherical shape for the moons of Mars, impact craters and such, but it is a little bit of a mystery if they are captured asteroids. One, how did Mars capture them? Mars has a small mass, and right now its atmosphere is too thin really for air friction, to slow down an object this size and let Mars gravity pull into orbit. So sort of an open question as to what's happening. Both of these moons, Phobos and Deimos, are tidally locked to Mars. They orbit close to the planet, and one face of the moon is always facing the planet. Interesting too that these moons discovered in 1877 were speculated on in 1726 when Gulliver Travels was written. The author put in that Mars had 2 moons, so pretty sure the author did not know about these moons with a telescope or any other speculation other than that Earth has 1 moon, Venus 0 moons, maybe Mars have 2 moons. Little graphic here that shows the speed of the orbit for the 2 moons, and it is interesting that Phobos has a length of time for its orbit about 7.6 hours. This time is smaller than the rotation time for the planet, 24.5 hours. So if you would put some post on Mars, the post would take 24.5 hours to go around once. But in that time, Phobos is going to have 3 orbits. 7.6 hours for its orbit, so multiply that Phobos by 3. If it was 8 times 3, that would be 24 hours. So Phobos moves more rapidly in angle than Mars rotates in angle. This has a consequence that Phobos will rise in the west. Phobos is moving faster than the horizon of the planet to an observer, and Phobos will rise in the west. Deimos, however, is a little bit slower than the spin of the planet. The time for orbit of Deimos, 30 hours, so the horizon of the planet is moving faster, and Deimos will rise in the east and set in the west, as our moon does. So Phobos and Deimos, small chunks of rock. They're in orbit around Mars. And let's move on to Saturn. Saturn has a large satellite, Titan, that has an interesting feature to it. I think in the 1940s it was discovered that Titan has an atmosphere by the characteristics of the light reflected by Titan. Now, it has an atmosphere that is comparable in thickness, in fact a little bit thicker than the Earth's atmosphere. It's cold, so the gases move more slowly, and Titan has accumulated primarily nitrogen atmosphere. Still not enough mass for Titan to hold on to hydrogen and helium. And the Cassini spacecraft arrived in orbit around Saturn in 2004. A very successful mission that's been giving us good information about Saturn, Saturn's rings, and the moons of Saturn. So Saturn's density, or sorry, Titan's density runs about 1.3 grams per cubic centimeter. Just for your memory, ice is about 1 gram per cubic centimeter, rock about 3 grams per cubic centimeter. So what do you think about the composition of Titan? Titan 1.3 grams per cubic centimeter. Well, it leans more towards ice than rock. Ice is 1 gram per cubic centimeter. Titan is 1.3 grams per cubic centimeter. In 2005, the Huygens probe was deployed and dropped through Titan's atmosphere and landed on Titan. As it was descending through the atmosphere, it returned photographs, and the dark pattern here, if this was taken on the Earth, what would you think this feature was, these dark streaks? Well, you might say drainage channels in a river, and this is the interpretation. Titan is at a temperature where methane is a liquid, and it is firmly believed that Titan has a methane cycle where methane rains down, is funneled by rivers into lakes, it evaporates and rains again. So there's a liquid on Titan. The liquid is methane. So when Huygens, the probe got down to the surface, it took a photograph here. The chunks are laying here are believed to be rocks of ice. Again, very cold, though the ice would be very, very solid and firm. And there's some speculation that the probe might have landed in a place where the methane river could have pushed these rocks around. Right now it's dry, but perhaps at some other season there's more methane rain and the rocks get pushed around like stream beds in the southwest United States. The Cassini spacecraft has radar and can penetrate through the methane haze very well, the methane haze that Titan has, and record the location of lakes on Titan. And again, fairly extensive. We compare to Lake Superior, one of our Great Lakes, and this particular lake on Titan is larger than Lake Superior. I don't know the depth of the Titan lakes. Probably, I would guess, not as deep as Lake Superior, but in terms of area, very large lakes on Titan, and made of methane, not made of water. The temperature is too cold for liquid water, but the temperature is okay for liquid methane. And more radar images, the impact crater here, and you can see some past impact craters at different spots here. But you can also see sand dunes. The winds on Titan push material around and form sand dunes. Another close-up here, impact crater. The graphic, legend on the graphic where I got this said this is about 25 miles across, this particular impact crater. And again, you can see sand dunes with material being blown along on the surface of Titan. And then using visible and infrared light and merging those photographs together, the white bands here are methane clouds, and again darker features, presumably methane enriched soil that gives that darker color. And then put it into motion, and here you go with a global view of Titan. There's some missing data where you see those blocks, but a view here of Titan as it rotates. And then Enceladus, another moon of Saturn. You can see features along the surface here. This is an ice surface, but there are cracks in the ice, and these cracks allow water to be expelled out into space, salty water. These streams have been measured in terms of what material is there, and so definitely know it's a water, kind of a salty water that's coming out of Enceladus. and call them geysers. There's again some internal heating from the tidal friction from Saturn, and we get liquid water, evidence of liquid water on this moon. Then moving on to Uranus with the infrared view of from an Earth-based telescope, and we can see the rings here, and then the satellites of Uranus. And what's interesting about them is that they're in the equatorial plane of the planet, and their orbits are perpendicular to the orbit of the planet around the sun. So this configuration where Uranus kind of lays on its side as it orbits around the sun has to be very old. These moons have that same orientation, and presumably these moons formed at the same time that Uranus formed, and we have just sort of confirmation that the equator of Uranus is at a strange angle compared to the equator of the Earth and its orbit around the sun. Voyager spacecraft flew by Uranus and photographed the surfaces of the moons, and at least some of the moons of Uranus. On to Neptune. Neptune has a very large moon, Triton, and you can see the surface here. It's believed that there are geysers, nitrogen geysers, and that nitrogen ice forms on the surface of Triton. It does allow, though, sunlight to come in through the ice and warm up the material underneath. That warming of the material creates pressure, and there eventually is a crack on the ice that covers that void where the energy is being absorbed, and we have a situation of a nitrogen gas coming out and forming a nitrogen geyser and carried debris along with it to create this different looking type of terrain. Now, Triton is an interesting satellite in that it is not like the orbits of the other major satellites in the solar system. Triton goes in the opposite direction to the spin of Neptune, and many people believe that it's a captured object that did not form along at the same time that Neptune formed. So there's a little survey of moons of our solar system. For Mars, 2 very small rocky moons, and low density, though, I should say. And then for Saturn, again, an abundance of moons, but especially some interesting ones. Titan with an atmosphere of about a little bit thicker than the Earth's atmosphere, a nitrogen atmosphere, and an atmosphere that has a liquid cycle to it. Liquid methane raining down, forming rivers and lakes. Enceladus with the ocean with water coming out in geysers between cracks in the ice. Uranus with its moons orbiting in the equator of the planet, and Triton, a probably captured object that is now in orbit around Neptune, as it has an orbit that's reverse to the spin of the planet. So another view of Triton with some of you can kind of see kind of an erosion effect as material is warmed up and sloughed off into space with the geyser effect, impact craters, and with that we stop. So another video, look for discussion of the rings of the Jovian planets.